I'm presenting work in collaboration with a pretty amazing PhD student who named Mathur, who's previously at Georgia Tech, but now has gone off into the ed tech world. I'm trying to draw him back into learning sciences CSCL, but we'll see where that goes. But he's really wonderful. So this is a collaborative project, interactive transcription techniques for interaction analysis. Kind of a quick overview of things we'll share, give a bit of background on interaction analysis, building off a little bit of what Lynn was saying, and this idea of integrative visualization that we've been working on for a couple of years. Share a bit about the empirical data for this little project, which is just a short video of classroom interaction from a kindergarten classroom that's well known in the IA community. And then our analysis, we're just going to interactively visualize this data set in 5 ways with a pretty well-known visualization programming language called D3JS. And that's going to support a discussion that has 2 parts. One is we're going to hopefully show a few techniques that might have some use, some interactive transcription techniques for interaction analysis. But we're also going to use it to kind of highlight some strengths and particularly some weaknesses of visualization programming languages like D3 for IA type work. So, quick background on interaction analysis. I'm sure most folks have heard of it on this call, but just as a high level, very established method in the learning sciences and CSCL communities. The screenshot on the left here was a foundational paper. It's really a method to look at how people interact with one another, the environment, objects, and a core part of it is kind of really detailed analyses of video records. The screenshot on the top right is a website. It's an excerpt from a website called Learning How to Look and Listen, which if you haven't visited, it gives a really quick, great overview of some of the leading figures who established the field and some really good videos and other stuff on that site. So I encourage you, sometime down the road, go check it out. And the bottom right, I think, is equally important. It was a recent paper by Deborah Silvis and a number of other really amazing young scholars. I thought Jasmine and Katie Taylor, I thought I saw them on the call, Rishi, but there's like 40 amazing people. But a big part of it is expanding the methodological commitments of interaction analysis. So I just think there's a ton of work there that's important to know about in relation to interaction analysis. One really key thing about IA, it's the kind of abbreviation for it, is you make transcripts from video. And typically, most of them look something like this. This is a transcript of a physics experiment in a kindergarten classroom from the video we're about to watch in a second. It shows turns of talk in very fine-grained detail. You get 21 lines or so of talk from teachers and students. You can do a lot with transcripts like this. You can do a lot with analyses of conversation. They're really text-focused. Even what are called multimodal transcripts might embed some still images, some video frames along here. Most of these transcripts are produced using Microsoft Word or Microsoft PowerPoint. So a big part of this talk is really exploring kind of using this idea of integrative visualization. How can visualization and visualization mediums amplify transcription as used in IA? What are the strengths and weaknesses? And how might you take transcription amplified by visualization and embed it in like a larger grounded theory process, or even use it to develop computational tools? So this talk is very much about taking IA and this idea of integrative visualization, transcription amplified by visualization, and kind of doing a small exploration of them together. So super quick, I'm just going to play this 10 seconds of this 2-minute video to give you a feel of this classroom. Again, this is a well-known video in the IA community.
Here we go. You ready?
Yep.
Yeah. Okay, here we go. Here we go.
So again, I hope the sound is good. If it's not, just let me know later. But we're in a kindergarten classroom. Teachers about conducting an experiment with a group of students huddled on the floor. There's talk. It's a bilingual classroom, so Spanish and English are both occurring. They occur in these 2 minutes. And so what I'm going to do now is Arpit's going to walk us through 5 different visualizations, interactive visualizations. They're kind of shown really quickly right here. We're going to walk through each one. These are all free and open source. I'll share the link in the chat if folks would like after this. But Arpit has created a little short video, and he's going to kind of talk like a visualization person would as he walks through each of these visualizations. So this is about a 5-minute video. If you can't hear him, just let me know in the chat, but I think this will sound good, hopefully.
In order to create interesting visualizations of this video, we broke it down into 3 data sheets. The first data sheet was the transcript that consisted of timestamped dialogues by every individual. Secondly, we created a position data sheet that had the pixel position for every individual and every individual's gaze for every 5-second timestamp. Finally, we created a volume data sheet with the volume in decibels and the source of the volume for every 0.2-second timestamp. Off of these 3 data sheets, we were able to create the following 5 visualizations. Begin by having a look at the word count lollipop chart. In this visualization, we have a list of all words that are uttered in the video on the y-axis with an associated lollipop glyph. Each lollipop glyph has a stem and a head. The length of the stem represents the frequency of the word spoken in the video. If we hover on a head, we can see the individual utterances for each word. We can also sort this visualization by ascending or descending order of frequency. For this visualization, we omitted all Spanish words and also common English articles and pronouns. Even with this simple visualization, we can generate a few useful insights. For example, even though the video is titled Matter Occupies Space, those 3 words are uttered only once in the video. We can see that the instructor instead relies on metaphors such as Coca-Cola, sand, bubbles, and dancing. We can also see a few names being uttered in the video, but we don't see that all students' names are spoken. Next, we take a look at the dialogue bubble chart. In this visualization, each ellipse represents an uninterrupted conversation turn. The ellipses are arranged across a conventional timeline, where the beginning and end of each ellipse represents the beginning and end of each conversation turn. The height of the ellipse represents the number of words that were spoken, and the color represents who spoke the dialogue. We can hover on ellipses to see exactly what was said. If we want to be a bit more precise with our comparisons across dialogues, we can change the glyph to a rectangular view as well. The visualization reveals several relevant insights regarding the general pacing of the conversation. Looking at the orange ellipses width and height, we can see that teachers speak for longer uninterrupted durations when compared to students. Hovering on the ellipses where students have a similar width or height, we can see that the only time students speak as much is when they're asking questions to the teacher in Spanish. On the timeline, we can also see lulls in conversation where no one speaks, and we can identify this as the time where the experiment is being performed. The overlapping of the ellipses also represents the phenomena of people speaking over one another. We can see while students are comfortable speaking over each other, they generally do not interrupt when the teacher is speaking. Next, we look at the word count unit visualization. In this visualization, each individual is represented as a spherical unit. The area of the spherical unit encodes the number of words uttered by the individual. We also judge the intonation of every dialogue to highlight the number of words that belong to questions. Expressions and exclamations were omitted for this visualization. By default, the units are arranged to mimic the cyclic position from the video, but the user can also arrange them in descending and ascending order of word count. This visualization is quite useful to analyze conversational parity and whether there are equitable opportunities to talk between students. We can see that surprisingly, the teacher frames most of our instruction in the form of questions. This visualization also highlights the differences in contribution between students, and we can clearly see that child 1 asks the most questions as compared to the rest of the class. We have a look at the volume scatter plot. As the name suggests, this visualization is a scatter plot where every point represents a 0.2-second instance from the video. The X position refers to the timestamp of the instance. The Y position refers to the volume of the instance in decibels, and the color represents the source of the volume. We can interact with the slider on the left to zoom in and out of the plot. As we can see, there are stretches of time with just ambient noise, and we can correlate this to be the time the experiment is taking place. We can also clearly see the sequential yet overlapping nature of the conversation between the students and the teacher. Finally, we have a look at the position and gaze diagram. In this visualization, every circle represents the pixel position of an individual at any given moment in the video. Similarly, the line represents the gaze or field of view for every individual. Users can interact with the time slider to analyze particular moments in the video. They can also interactively select which students they want to focus their analysis on. This visualization highlights the ebbs and flows of how attention is collected and released.
Okay, so I'll sum up with a little discussion here that highlights two parts. I hope the sound and everything are sounded okay there. First off, those are all pretty simple and standard visualization techniques, rarely applied to this type of data, but it's not a jump to take a transcript, drop it in, and automatically produce those for much larger data sets. Now, on one hand, there are some strengths hopefully here. You can see some of those techniques, the pace of conversation, turn-taking patterns, overlapping talk, even just volume of conversation. They provide a really different look at some of those things in comparison to a traditional transcript. Other things like the interactive unit visualization provide really different ways to kind of see equitable opportunities to talk. With all that said, of course, they miss a ton from what a normal transcript in a Microsoft Word document might contain, though interaction with many of those visualizations, you can, of course, read, talk, and do that same level of analysis. All that to say, I think another equally important thing. So hopefully there's some value there, as those are 5 interactive transcription techniques for interaction analysis. There's probably a bunch others. But I think a main thing for Arpit and I that we wanted to hit on is, D3JS is a classic, very well-known visualization programming language, really a grammar or a formal model of describing visualizations, including data, transformations, scales, and visual marks. If you're in the Viz community, if you're in kind of the computer science world, you're talking in those terms, right? Such grammars were designed for data that's already structured, as you saw a CSV file, typically characterized as raw or objective, and doesn't focus, they were never intended to focus on depicting people's interaction or complex learning ecologies like classrooms, right? And so we think kind of for interaction analysis, for learning sciences, for CSEL, we think there's this opportunity to expand the notion of a visualization grammar to more deeply consider how people and context are represented. And we see that work kind of very much in line with some of that work I shared earlier, expanding the methodological commitments of interaction analysis. For us, things we're working on now, we're working on developing interactive glyphs for interaction analysis specific to different types of settings, kind of different libraries than D3 that might be able to work with video and standard visualization grammars kind of together simultaneously. And certainly others are doing some of this too, but interaction techniques that might be able to take on the perspective of people, participants who are engaged in interaction. So, again, just kind of summing up, hopefully some of those techniques are valuable. It's not a jump to be able to apply those to many different types of conversational and video data sets. But at the same time, we think there's a ton that's not just lost, but there are assumptions made by some of these visualization grammars and programming languages that we as a community should talk about together. And there's a lot of people doing related and really interesting work here. So thanks for the time. And yeah, would love any questions.